Network protocols. Network protocols are a set of rules that computers and network devices follow in order to communicate with each other. Let's consider this example where a computer A wants to communicate to computer B. There could be various reasons why computer A wants to communicate to computer B. It might want to share a file, it might want to send an instant message, or it might be sending an email, or even requesting a web page from computer B. But how would computer B know how to respond to computer A? This is done using protocols. Protocols help computers to understand what is being sent or requested for. There are protocols defined for all types of communication. To send an email, we have the SMTP protocol, which stands for Simple Mail Transfer Protocol. To access website, we have HTTP, Hypertext Transport Protocol. To transfer files, we have FTP, File Transport Protocol. So like this, there are protocols defined for every types of communication. So where is this protocol information put? How does the destination computer gets to know what the source wants? This protocol information is embedded into all the packets in a communication. When computer A wants to communicate with computer B, it does so in the form of exchanging packets. In the first communication here, computer A is sending an email using SMTP protocol. In the second communication, computer A is sending a file using File Transfer Protocol. The industry experts thought that instead of putting the protocol information in the packet, why can't we just represent each protocol by a number? As you know, carrying an integer is lighter than carrying a string value. These numbers that represents protocols are called as port numbers. Again, let's consider the example of computer A sending an email to computer B. Now, instead of embedding the protocol information, computer A will put in the assigned number for SMTP in the packet. For SMTP, it is 25. So we could say that the port number for SMTP is 25. You might be wondering, how does the computer know 25 means SMTP? To understand this, let's learn a little bit more about port numbers. In a packet, 16 bits are reserved for carrying port numbers. Since there are 16 bits, we can have values from 1 to 65,535. Port number 1 to 1024 are called as well-known ports. These are assigned to commonly used protocols. They are also called as standard ports. This is how computers understand 25 means SMTP, 80 means HTTP, 53 means DNS, etc. A packet has both source port number and destination port number. 16 bits for source port and 16 bits for destination port. As learnt in the past, source port is randomly chosen by operating system. Usually it will be greater than 30,000. Destination port depends on the protocol being used, example SMTP 25, HTTP 80, etc. It will come really handy to memorize few commonly used protocols and their port numbers. Pause the video and take a look at these commonly used ports and protocols. All the different protocols can be put into two protocol suites, which are TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. The two suites are created to address two important needs of communication. First is the reliability, and the second is speed. TCP is used in places where quality is more important than speed. UDP is used where speed of delivery is more important than the quality. Let's take a closer look at these two. TCP is a reliable protocol. It means it ensures the delivery of each packet without any error. This is achieved by acknowledging every packet that is being sent. If the acknowledgement is not received within a certain period of time, the packet is retransmitted. Let's consider computer A wants to send some file to computer B. We have learned that a packet can only carry 64 kilobyte of data in it. Because of this, the transmission of file will be broken down into multiple packets. We want to ensure two things. The destination system knows how to rearrange all the packets in the right order. And second thing, all the packets have to be transmitted without fail. To achieve these two things, we have sequence number and acknowledgement number. Computer A sends every packet with sequence number in it. It will wait for the acknowledgement for each packet it has sent. If A does not receive an acknowledgement for a specific packet within a specified time, it will retransmit the packet. In the example shown, the acknowledgement for sequence 3 has not been received. So, computer A will send the packet again. By now, you would have already guessed the advantages and disadvantages of TCP. The advantage is it is reliable and guarantees the delivery. But it would obviously be slow as it waits for acknowledgements for every packet. Then what would one do if they need to transmit data fast? When speed and being real-time matters more, the UDP protocol is used. Here we are not really concerned about the guaranteed delivery, and that's why UDP does not need any acknowledgements or retransmissions. You might be wondering who wants to use such a lousy protocol. You will be surprised to know that we need UDPs as much as we need TCP. Let's take an example of a WhatsApp call between Bob and Alice. When Bob says, "Hello, how are you?" it might be broken down into 100 packets. Here, speed of delivery is more important. That's why if there are few packets lost due to network issues, there won't be any retransmission. Even if there are few packets dropped, there will be a slight glitch in the call, which is acceptable rather than waiting for all the packets to arrive at the destination and then rearranged in the right order before Alice could hear the message. In that case, it does not sound real time. So, in streaming media, VoIP calls, and online games, UDP is heavily used. Let's highlight the difference between TCP and UDP more clearly. TCP stands for Transmission Control Protocol. TCP stands for Transmission Control Protocol. UDP stands for User Datagram Protocol. TCP is connection oriented, whereas UDP is connectionless. TCP has acknowledgements for each packet transmitted. There are no acknowledgements in UDP. Failed packets are retransmitted. There is no concept of retransmission. TCP assures a guaranteed delivery. UDP is known for best effort delivery. TCP is reliable, whereas UDP is not reliable. TCP is slower because it has acknowledgements, and UDP is faster. Example protocols within the TCP suite include HTTP, HTTPS, SMTP, SSH, etc. For UDP, the protocols include streaming video protocols, VoIP protocols, online gaming protocols, etc. It is worth noting that the connection orientedness in TCP is achieved by a process called as three-way handshake.